Hi guys, in this video I will talk about motion. First I will talk about motion in one dimension. So let's understand the difference between distance and displacement. Distance is the actual length covered by the object during the moving from the initial to the final position, and it's classified as a scalar quantity. A scalar quantity is the quantity that can be described by just magnitude, no direction. Displacement is the length of the straight line drawn from the initial position of the moving object to the final position, and is classified as vector quantity. Here, vector quantity is the quantity that can be described by both magnitude and direction. Note that displacement also can be defined as the change in position. If the object is moving in x-axis, the displacement will be delta x, while if the object is moving in y-axis, the displacement will be delta y. Delta x is equal x final minus x initial. X final is the final position on x-axis, and x initial is the initial position on x-axis. While y final is the final position in y-axis, and y initial is the initial position on y-axis. Okay, let's solve this question. The following graph shows the position of an object during moving from point A to point C. Depending on the values, find the position of the object at the points A, B, C. First, the object here is moving in x-axis, so the position will be x. For A, we say xa equal 2 meter, xb equal 10 meter, and xc equal minus 8 meter. So the position of A is 2 meter, position of B 10 meter, position of C is minus 8 meter. The distance covered by the object during its moving from point A to point C during B. From A to C during B, this means from A to B, then from B to C. The distance from A to B is 8 meter. From B to C is 10 plus 8, this means 18. So the total distance will be 8 plus 18, 26 meter. C, the displacement that the object makes when it's moving from point A to point C during point B. From A to C during B, this means from A to B to C. But for displacement, the most important is the initial position and the final position. So delta x from A to C equal xc minus xa. So it will equal minus 8. Xc, we found it before. Xc is minus 8. And xa is 2 meter. So minus 8 minus 2, this means minus 10 meter. D, the displacement that the object makes when it's moving from point C to point B. From C to B directly. The displacement from C to B will be delta x from C to B. This means xb minus xc. xb 10 minus xc, which is minus 8. So the answer will be 18 meter. Let's check from the graph. From C to B directly, if we draw one line from C to B, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it will be plus 18. This means right side. We move right side 18 meters. So this one displacement from C to B. Now this example, when the object moving in y-axis, we need to find the position of the object at the points A, B, C. So here, YA equal minus 8 centimeter, the unit is centimeter. YB is 9 centimeter, YC is 1 centimeter. The distance covered by the object during its moving from point A to point C during point B. The distance from A to B plus from B to C will equal from minus 8 to 9 is 17, from 9 to 1 is 8, so the total will be 25 centimeter. The displacement that the object makes when it's moving from point A to point C during point B. The most important is the initial and the final position, so delta y from A to C equal yc minus ya. Yc is 1 centimeter, ya is minus 8 centimeter, so 1 minus minus will be positive. 1 positive will mean 1 plus 8 will be 9 centimeter. So from A to C directly is positive, mean positive y-axis. We will move 9 centimeter in positive y-axis. The displacement that the object makes when it's moving from point C to A, from C to A directly, will be the same answer but in negative direction. So the displacement from C to A will equal YA minus YC. YA is minus 8 and YC is 1. So minus 8 minus 1 mean minus 9 centimeter. So the displacement from C to A is minus, mean we will move in negative y-axis 9 centimeter. Here we will talk about two cases of motion, which is motion with constant speed and motion with constant acceleration. For the first case, suppose we have car moving with constant speed and we ask the guy inside the car to throw one stone each 1 second. So here, when the time was 0, the speed was 5. After 1 second, the speed is still 5 meters per second because the car covered the same distance during the same interval of time. For example, in the first second, the car covered 5 meters, and we know that the velocity equal distance divided by time, so it will be 5 meters divided by 1 second will be 5 meters per second. So here the speed is constant during the time. If we illustrate the relation between velocity and time, it will be straight line, and this line will be horizontal, no angle. So here, for the first second, the speed was 5. Also for second, the speed is still 5. Third second, the speed is still 5. To find the acceleration, we need to find the gradient. The gradient is delta y divided by delta x. Delta y mean y final minus y initial divided by x final minus x initial. Y mean y-axis, which is velocity. So it will be v final minus v initial divided by t final by minus t initial, because x is the x-axis, which is time. If we took 2 points, for example, this one and this one, the t initial will be 1, the t final will be 4, the v initial will be 5, the y final will be also 5. This will be 5 minus 5 divided by 4 minus 1 will equal 0. So we don't have acceleration. This means we don't have increase or decrease in the velocity. In the second case, we have acceleration. So the speed of the car is increasing with time. Here, when the time was 0, the velocity was 0. After 1 second, the velocity become 5. After 2 seconds, the velocity become 10. After 3 seconds, the velocity become 15. So we have increase in the velocity, which is 5 meters per second. To illustrate the relation between velocity and time, we do this graph. In the first second, the velocity was 5. Then in the second, the velocity become 10, then become 15. So we have gradient. The gradient here equal the acceleration. To find the gradient or the slope, we choose 2 points, which is this one and this one, for example. So the final velocity is 15. Initial velocity is 5. 15 minus 5 is 10. The final time is 3. The initial time is 1. So 3 minus 1. 10 divided by 2 is 5. 5 meters per second square. So the acceleration is 5 meters per second square, which means that the velocity is increasing by 5 meters per second per 1 second. If we have constant acceleration, we can use these formulas. And here I will explain. If we talk about motion with constant acceleration, we can use this. In the case of motion with constant acceleration, we can use these formulas. And here I will explain how we got the first formula. As we mentioned before, acceleration is the gradient, which is the change in velocity divided by the change in time, which means v final minus v initial divided by t final minus t initial. Supposing that the initial time is 0, so this will become v final minus v initial divided by time. By cross product, v final minus v initial equal t multiplied by a. So we will go to this formula. Then we move minus V initial behind the equal or after the equal, then become V final equal V initial plus AT. So this one, the first formula. Okay, let's practice these formulas. Example 3. A car starts moving from rest with constant acceleration of 5 meters per second square. Find the speed of the car after 3 seconds. First, and before you answer any question, you need to know what is the required and what is the condition. For example, is giving in the part A or part 1 that the time is 3 seconds and the required is the speed. So you need to write the required and the condition. Okay. In this example, a car starts moving from rest with a constant acceleration of 5 meters per second square. Find 1. The speed of the car after 3 seconds. To answer this question, first you need to know what is the required and what is the condition. And then you can know which formula you can use. For example, in the first case, the requirement is the speed. So we need to find V final, and the condition is when t equal 3 seconds. Then you need to find the formula that have V final and t. For example, the first formula have V final and t, but the second formula, we have t, but no V final. The third formula, we have V final, but we don't have t. So we don't have another choice. We just have one formula to use. Okay, let's answer some examples. A car starts moving from rest with a constant acceleration of 5 meters per second square. Find the speed of the car after 3 seconds. Here we need to find the speed after 3 seconds. So the required is the speed and giving is the 3 seconds. And the giving is the time, which is 3 seconds. Let's start to answer. Let's answer some questions. Let's do some example. Okay, let's do some example to understand how we can use these formulas. A car starts moving from rest with a constant acceleration 5 meters per second square. Find 1. The speed of the car after 3 seconds. So the required is the speed and the condition is 3 seconds. So the question gives us the time, which is 3 seconds. Here, to choose which formula we must use, you need to write like this: the requirement and the condition. So we need to find V final when t equal 3 seconds. So we need to find formula have V final and t. The first one have V final and t. The second one, we have t but no V final. The third one, we have V final but no t. So we need to use the first formula. V final equal V initial plus AT. V final, we need to find it. V initial is 0 because a car starts moving from rest, mean V initial is 0. The acceleration is 5, is giving in the question. Constant acceleration of 5 meters per second square. And the time is the condition. Here is the 3 seconds. So we just multiply by 3. The answer will be 15 meters per second. For the second part, a distance that the car covered during 4 seconds. We need to find the distance, which is delta x, when the time is 4 seconds. We need formula have delta x and t. This one t, no delta x. This one delta x and t, so we can use the second one. The third one, we have delta x, no t, so we just have one formula to use. Delta x is will be initial t plus half at squared. Delta x, we need to find it. V initial is 0. Plus half, A is 5, is giving here, and T is 4, is condition. So the answer will be 40 meters. For the third part, the speed of the car when it reaches a point, which is 40 meters far from the starting point. So we need to find the speed of the car. So we need to find V final when the distance is 40 meters. So we need V final when distance is 40 meters. The formula that have V final and X, this one V final no X, this one X no V final, this one V final and X. So we use the third formula, V final square equal V initial square plus 2AX. Now V final, we don't know how much V final, but V initial is 0, A is 5, delta X is 40. So the answer will be 400. This one for V final square. For V final, we take the square root of 400, which equal 20 meters per second. For the fourth part, the time that the car needs to reach a point which is 90 meters far from starting point. So we need to find the time when distance is 90 meters. We need to find the time when distance is 90 meters. We need formula have T and delta X. T, no delta X, X with delta T, I mean delta X with T, so we use the second formula. Delta X is equal V initial T plus half AT square. Delta X is 90, V initial is 0, half A is 5, T square is needed, so 90 equal 2.5 T square, so T square equal 90 divided by 2.5 is equal 36, so T will equal the square root of 36, which is 6 seconds.